Hi everyone, Kurt with Hypnodyne again. We've already looked at the ZLab sleep study management software in a previous video. Today I would like to show you some of the new stuff. For instance, this is the automatically calculated hypnogram. When you upload a file, it's set as not processed. And when it gets this little tag here, it means that a batch job at the back end went into the file and examined it and produced a bunch of different information that we're going to see now. And then it puts this tag processed. So when it's processed, that's the time to open the recording and to look at the situation. So we've got the spectrograms, as was also the case in the previous video, but then we've got a hypnogram. Now the hypnogram is automatically calculated. I haven't finished moving all of the scoring logic onto the batch job, so this is still not the best case possible hypnogram. Let's say we're 60% there. But you can already see that it has identified the correct sleep onset, N2, N3, and then it's marked the eye movements as REM. And then there's a slightly controversial aspect of it as well, which is to mark the major body movements as wake. I understand this is not the AASM practice. I'm doing it right now just to, that's the way it makes more sense to me, but I'll probably change it in the future, have both options. Anyway, once you get this, what you want to probably do is open the recording and see if you can do better than the software at fixing up the hypnogram. So you have two slots that are open for each recording. So you simply copy from the automatically generated hypnogram, paste in one of the slots, and then you click on the slot. Once you click on the slot, the HD Score software is automatically opened, and the information, the extra information that's produced from the batch job has already been imported into HD Score. Now it's calculating the spectrogram at the top. This now I'm running it in debug mode. So it's a lot slower, but that doesn't really matter. We've got a few more options than the last time. For example, we can hide the hypnogram to look at the heart rate plot right here in yellow. And I'm going to actually let it, okay, it's done it. So with the mouse wheel, you can change the contrast on the spectrogram, switch back and forth to X-ray mode if you need to. But already we have some interesting findings. For example, the heart rate here keeps changing because this is a wake period. Let's turn on the hypnogram again. Then the N1 phase was correctly determined. If we take a look at this transition, we have slow eye movements. And then N2 starts in conjunction with the appearance of spindles. So this is a very, very accurate transition in sleep onset determination. And then, for instance, it has determined that the patient goes into N3 sleep right about here, which makes sense, also looking at the spectrogram. Now, once all the features are imported, oh, by the way, you also get the BPM here near the PPG waveform, which you weren't getting the last time. So this is now 61 BPM. And then, for example, if you move over here, this is a REM phase, and it's gone up to 82 BPM. So that's interesting. But anyway, I'm just going to switch it to feature mode. Here you can see all of the stuff that was extracted by the batch processor. And it looks like a low pixel image because here every epoch has a different value. So it's not trying to interpolate, it's just telling you what it found for each particular epoch. You can go to 1-to-1 if it bothers you that it's stretched out like that, but I think it's fine. So anyway, one of the most useful plots is the plots of delta waves in blue against rapid eye movements in orange, against slow eye movements in this beige color. And you can see that the sleep onset there works quite well. Now, some people have very strong delta waves, and you will see a nice full envelope here, but that's not always the case, and that's why you can't just use delta waves to determine the sleep phases. Here you have a separate envelope that's much fuller and much more precise, that's taken a look at the sleep spindles, and in fact you see that the beginning and end of these periods of spindles corresponds with the sleep cycles. For example, here the spindles end and the rapid eye movement activity begins. Lower than that, there's the correlation map, and the correlation map usually is mixed or positive during non-REM sleep, and it's highly negative during REM sleep. So that's another type of feature that got extracted that you can use to validate what you're looking at up there. Then you have a complete map of the movements, including movement artifacts for the left and, sorry, what is this? Yeah, so the movements are not just taken from the accelerometer, they're also calculated from the EEG, and that's why there are two different channels to that, because the accelerometer itself wouldn't have channels, but it doesn't matter. Then there's position changes, and these are periods in which the person actually changed position, like they began to sleep in a different position. In this case, they're very overlapped, except perhaps this vertical bar right here and this one right here. So just to examine what we're looking at, let's go and pick that. And I'm going to zoom into the EEG again, and also the accelerometer data again. So let's look at a difference between here. So here's a point in time in which the position was actually changed. Now to see that, you would remove the filtering on the accelerometer, because that's what allows you to see the three lines. They change order. This brighter green one goes to the top. That means that the actual position of the patient changed. I used to have a plot of the head position here before. I don't have it anymore. I probably will have it again soon. But anyway, here we have confirmed that this is an actual position change. But then if you go onto this bar right here, I'm trying to catch this bar that shows only in green without the white. You can see that there was no change in the order of the lines. And so this is just a movement without a position change. Now, if somebody's sleeping with their spouse, you might see a lot of these. There is movements without position changes. By the way, what I mean with position changes is change in the orientation of the head worn sensor, which most likely corresponds to a change in the sleeping position. But I was saying, if somebody's sleeping with their spouse, you will see a lot of these green ones without the white, which means it's not them moving, it's just the mattress bouncing them around. Then below that we have artifacts, several types of artifacts indeed. This recording was acquired with the memory card mode, so there are no gaps in the radio signal, so you don't see any yellow. If this was a radio recording and, for example, you place the computer too far away from the transmitter, you might see some yellow marked epochs. But in this case, we only have regular artifacts. So the artifacts that we see include both EMG and EEG artifacts. The EMG artifacts are periods in which you have a lot of high frequency activity, and EMG artifacts might be something like this, where the signal is actually clipping or going up too fast in a way that's not consistent with any underlying physiological activity, so it must be some kind of perturbance. And below this is actually quite important. It's one of the most important indicators. This shows you how much sweat the person produced throughout the night. Now, sweat is a negative thing if you're trying to get a very clean EEG, because let's say let's go to a period of high sweat. You see what happened here. In fact, I'm going to turn off the filtering. See this big mess. This is unavoidable. If the patient is sleeping, all of this, the skin produces electric potentials, and so this is what it looks like. Now, fortunately, the headroom of the amplifier is huge compared to the signal that's actually useful. This was one of the milestones in the latest versions of the hardware, which means that there's nearly no clipping. And I think here the signal is not really clipped, because if it were clipped, then you would have some of these red indicators. This is simply the zoom limit of the software. But so that's important, because even though all this interference from the sweat is going on, still we're not losing the signal. So you have the spindles clearly visible here. And the result of that is that when you go onto the X-ray, you have an uninterrupted band. So that was a major milestone in the hardware development. And But you can see that there's sweat activity by looking at these two blue curves. The reason there are two is because I'm using two different ways of indicating sweat activity. Sometimes one works better than the other, but that doesn't matter. You have both. They're sort of happening in the same regions, which is good. So you have some sweat beginning here, and if I were to go over to this side, we wouldn't have any sweat. In fact, we don't. And then when we come to that area, we start seeing some sweat. And then finally, this should be the period of highest sweat. There we go. Now, when the signal is actually clipping, which should be very rarely and only in conjunction to major body movements, you will see this red indicator. So let's see if we can find that zone where the signal actually clipped. Okay, so here it probably actually clipped. There was a major movement. You can confirm with the accelerometer. So now, all of these things are very interesting features to get extracted. And the reason for that is that to get these features out, you don't just look at the features, but you have to have a catalog of every possible artifact that can happen. And that catalog needs to be elastic so that it has a way of adjusting itself to the particular type of artifact that you're indeed seeing in that particular patient, because not everybody's sweat is the same, not everybody's EEG artifacts are the same. Yeah, and then you need to make sure that you don't consider all of these artifacts when you're extracting the features. And I don't just mean take these areas and zero out those areas out of the other waves. That's naive. There's a lot more that you must do. For example, there's a lot of different thresholding that goes on to extract these curves, and the thresholding has to be done only after the artifacts are removed. But the good news is that I've done all the work for you, so you can just focus on using, for example, these artifacted areas to remove those from whatever type of computation you're trying to do on your acquired sleep data. You can, for example, if you're trying to figure out a delta wave intensity, you'd know that you probably don't want a recording that's this poor in terms of sweat, because it's actually quite tough to discriminate between sweat and delta waves. They're completely overlapping in frequency. In fact, to get the hypnogram correct, in spite of the sweat, it's quite an undertaking. So like, for example, here it's correctly detecting that this is N2 sleep instead of N3 sleep, even though there's a ton of sweat going on. So if we go and take a look, and now I've sort of messed with the scaling. So let me get the scaling back to normal and go back to filtering. So for example, this did not get interpreted as delta waves, neither did this, otherwise this epoch would have been marked as N3. The algorithm is intelligent enough to figure out that this part is exactly the same as this part. That is, it's mostly flat. There's no delta activity, even though this activity right here, you can see in the spectrogram, if you change the color especially, that you see there's no spectral factor by which you can discriminate sweating from delta activity. It looks like a whole continuous smooth process of increasing low frequency activity. So this is quite an achievement, quite an undertaking that this is being able to be ignored successfully, so that the algorithm does consider this portion as N2, which it is, instead of N3. But as I said, you've got it all marked right here. So for example, if you're doing some experiment on the precise amount of delta activity, you might want a recording that's pristine without sweating. So anyway, these indicators, they're all available in plain text in the directory in which this particular record is stored. I can go to Open Folder, and then under X for extended or extracted features, you have all of these features in plain text. For example, if you want to go to the movement map, this is just an array of values, one per epoch, that you can import with any software that you're writing. Everything that I showed you here in these colored charts is available in plain text as soon as the recording gets processed. Now, the way that I envision this working, as I mentioned the last time probably, is that you do as I did, which is to copy the hypnogram that was calculated into a new hypnogram, and then you check if there's any problem with it. For example, here we've got some eye movements that didn't, yeah, this is definitely REM. So you might want to, for example, extend the REM phase here, add a few REM epochs. As I said, the hypnogram calculation is not completely transferred to the new code base yet. But then when you're done, you click Send Scoring to ZLab, and you see that now we've updated our hypnogram and it's stored on the server, and any other investigators that are connected to this study will see the change. And that's it. And this is also stored both on the server and in plain text in our directory here. So that would be, for example, hypnogram 0, I guess. And I'm just checking something. Is it hypnogram 0? No, it's hypnogram 1, so I had to anyway click. So you have both these hypnograms, and if you create a new one, then you're going to have all three. For example, you could, well, maybe you don't want to copy and paste, you just want to start from scratch. I'm just going to mark a few epochs, send scoring back, and now you have a third hypnogram. So this is all available in plain text. Remember also that you have the investigator notes with the automatically extracted hashtags, and you can use all of these for processing and doing your own calculations or your own investigations. I'm thinking if there was anything else. I think that's probably it. These hypnograms and all these extracted features come in minutes after you have uploaded the recording, and so now there's a complete system that sleep researchers can use to do their studies. Oh, this is what I forgot. That is that in normal circumstances you'd be on the scorer, and then once you've done everything that you needed to do, for example, you might want to email this participant and tell him, hey, turn on the aircon so that you stop sweating. But then once you're done, you set the record to reviewed, and then now you have a reviewed record which tells you this is done, you can move on. And of course this is updated, and now it's telling us that you have reviewed 3 out of however many records is your target for this study. Okay, so this is the update for today. I think I don't have anything else for the time being, but if I think of anything else, keep stay tuned. Keep watching for new videos. Thanks for watching.